Rhizodeg is one of the newest and most well-known types of insulin on the market. But what kind of insulin is it exactly? How do we calculate the required insulin doses during the day? How can we measure blood sugar changes after each meal, and how do we correct them? And what about high morning sugar levels before breakfast? How should we deal with that? This video is very important, full of details. Stay with me. Peace be upon you all. I'm Hussein Lotfi, and you're watching the Octopus Pharmacist channel. Welcome to a new episode of From A to Z. At the start of today's video, here are the main topics we will cover. And this time, I won't tell you to just jump to the minute of the title that interests you. No, I want you to stay with me from the very beginning until the very last minute, because every point and every piece of information here is very important. It will help you avoid dangerous mistakes that can happen when using insulin. The first topic, what are the types of insulin available in the market? We'll review them together. I'll give you simple, clear details about each one. And remember, we've already explained insulin in detail before, but today we're focusing on the main points. Insulin in the market is divided into three main types. And for every type, we must remember three important details. 1. Onset of action. What does this mean? It means the time insulin takes after injection to start showing its effect in the blood. Is this good or bad? Well, if I want to lower my blood sugar after a meal, the shorter this time is, the better, because it works quickly. But be careful. If someone injects this type of insulin and doesn't eat quickly, their blood sugar can drop too much, and hypoglycemia may happen. 2. The peak of insulin. What does peak mean? It's the highest level that insulin reaches in the blood after use. A higher peak means a stronger drop in blood sugar. This can be dangerous. For example, imagine someone injects a type of insulin whose peak comes after 8 hours. They eat just a little food, then go to sleep. The food gets digested and used up, but the insulin is still peaking strongly while they are asleep. The result could be severe hypoglycemia, and sometimes even death. So, the closer and lower the peak is, the safer it is. 3. Duration. How long will the insulin stay in the blood and cover the body? This helps us decide how to schedule doses during the day. Based on these 3 points, insulin is divided into 3 main types. 1. Short-acting insulin. This category itself has 2 subtypes. The old type, called regular insulin, you'll often see the letter on it. It's clear in appearance, soluble, crystalline zinc insulin. Its onset is after 30 to 60 minutes, so it should be injected about 15 to 30 minutes before meals. Its peak appears after 2 to 4 hours, and it lasts for about 8 hours. The new type, called rapid-acting insulin. There are 3 main examples: Oaspart Novorapid, Olispro Humalog, O-glucine Apidra. These are much faster. Their onset is just 5 to 15 minutes. So we advise patients, inject while sitting at the table just before eating. If you delay eating, blood sugar can drop quickly. Their peak is around 30 minutes to 2 hours, and the duration is only 3 to 5 hours. Why are these new types special? Because they imitate the body's natural insulin. Remember, our bodies produce insulin in 2 ways. O, basal insulin, always present in low levels, steady with no peak. O, bolus insulin released in high amounts with meals, then goes down again. Rapid-acting insulin mimics the bolus type. 2. Intermediate-acting insulin. This is usually NPH insulin, which is insulin mixed with zinc and protamine. You'll often see it sold as NPH or N. A well-known brand is Humulin N. Onset, 1 to 2 hours. Peak, 5 to 10 hours. Duration, 10 to 16 hours. Why is this considered old? Because it was designed to mimic basal insulin, but real basal insulin has no peak. This one does, and it comes late. That's risky, especially at night, when it can cause low sugar during sleep. This type can also be mixed with short-acting insulin. That's called pre-mixed insulin. For example, 30/70 mix where 30% is rapid or short-acting and 70% is intermediate. 3. Long-acting insulin. These mimic the natural basal insulin of the body with no peak and steady coverage. They usually last 24 hours or more. Currently, we have 3 main types. Detamir Levemir covers about 10 to 24 hours. Often, it doesn't last a full 24, so patients may need 2 injections a day. Glargine Lantus Tugio covers about 20 to 24 hours, usually given once a day. Degludec Tresiba, an ultra-long-acting insulin, lasts up to 42 hours with no peak. This makes it the safest against hypoglycemia. Because it doesn't peak, the risk of sudden blood sugar drops is very low. The best modern regimen. Today, the best approach is the basal bolus regimen. This combines a long-acting insulin for basal coverage, a rapid-acting insulin before meals to handle food-related sugar rises. This way, we mimic the body's natural insulin system as closely as possible. The second topic, how do we give insulin throughout the day? We'll discuss in detail how doses can be scheduled, twice a day, 3 times, 4, or even 5 times a day. Each method has its own rules and benefits, and we'll explain them step by step in this part of this episode. These types of insulin injection methods are called MDI, multiple daily injections. We actually have 3 main ways to give insulin. Let's review them together. The first method, basal bolus system. This is the best and most effective method. How does it work? At bedtime, the patient takes 1 dose of long-acting insulin. Then, before breakfast, lunch, and dinner, the patient takes a dose of rapid-acting insulin. That's the standard form. But in one special case, if the chosen long-acting insulin is detamir, the dose doesn't last 24 hours, only about 12 hours. So, the doctor splits it into 2 doses instead of 1. This first method is the best choice when the doctor prescribes newer types of insulin, the rapid-acting and the long-acting ones. The second method, pre-mixed insulin. Here, the insulin pen or vial already contains a mixture of rapid-acting insulin and long-acting insulin. In older types, the mix is usually 30% rapid-acting and 70% intermediate R and N, such as Mixtard. In newer types, the mix may be different, such as Rysodeg. This method is used twice a day, 2/3 of the dose in the morning, 1/3 in the evening. The third method, old insulin regimen. This method is based on older insulins, a dose of NPH at night, plus regular insulin after breakfast and after lunch. This approach is less common today, but is still important to know. Important notes before we finish. 1. If I'm using the modern insulins, rapid plus long-acting, then I'll follow the first method. 2. If I'm using the older insulins, R and N, then I'll follow the second method. 3. If I'm using a pre-mixed insulin that contains NPH, then I also follow the second method. 4. Sometimes the doctor decides to add only 1 type of insulin. This happens when a patient is already on 3 oral diabetes medications, but the sugar level is still uncontrolled. In that case, the doctor may add just a small dose of long-acting insulin, usually around 8 international units. The third topic, how to calculate insulin doses. This is one of the most important points we will talk about today. So let's go step by step. Point 1. The doctor will always calculate your dose based on your body weight, and this number will be written clearly for you. Point 2. When starting insulin, doctors usually begin with small numbers, 0.3, 0.4, or 0.5 units per kilogram of body weight. Why small doses? Because at first, the patient is still learning how to use insulin, and the goal is to avoid complications, especially hypoglycemia. Later, the doctor will gradually adjust and increase the dose, depending on how the patient's blood sugar responds. Point 3. The doctor will also decide which insulin system to use. The modern system, rapid plus long-acting. The old system, regular plus NPH. or the premix system. Let's see, step by step, how the total dose is calculated. Step 1. Calculate the total daily dose, TDD. How do we do this? Multiply the patient's weight in kilograms by the chosen starting factor, 0.3, 0.4, or 0.5. Example. A patient weighs 100 kilograms. The doctor starts with 0.3. So, 100 times 0.3 is equal to 30 units. This means the total insulin for the entire day is 30 units. We now need to divide these 30 units according to the type of insulin chosen. Step 2. Divide the total dose based on insulin system. A. Premixed insulin, 70/30ths. 2/3 of the dose is given in the morning. 1/3 is given in the evening. In our example, 20 units in the morning, 10 units in the evening. This is always given as 2 injections per day. B. Modern system, rapid plus long-acting. Here we divide the dose 50/50. 50% goes to long-acting insulin. 50% goes to rapid-acting insulin, divided into 3 meals. Example with our 30 units. 15 units long-acting, e.g. Glargine/Lantus at night. 15 units rapid-acting, e.g. Aspart. Given as 5 units before breakfast, 5 before lunch, and 5 before dinner. C. Old system, regular plus NPH. Here the dose is divided into 3 equal parts. 1/3 for NPH at night. 2/3 divided into regular insulin before meals. Using our example of 30 units. 10 units NPH at night. 10 units regular before breakfast. 10 units regular before lunch. Step 3. Special cases. If the doctor chooses a modern premixed insulin like Rhizodeg, rapid plus long, in a 70/30ths mix. Again, the system is 2 injections per day. 2/3 of the dose in the morning, 1/3 in the evening. For our 30 units, 20 in the morning, 10 in the evening. If the doctor chooses Detamir-Levemir as the long-acting insulin, it doesn't last a full 24 hours, only about 12 hours. So the dose is split into 2 injections instead of 1. Applying it to our example, total equals 30 units. Half, 15 units, is long-acting Detamir. Split into 7 units in the morning and 8 at night. The other half, 15 units, is rapid-acting divided as 5 units before each meal. In this case, the patient ends up taking 5 injections per day. And this is how insulin doses are calculated step by step. Starting small, calculating the total daily dose, and then dividing it according to the system chosen by the doctor. The 4th topic for today is very important. It often confuses people. They think it is complicated, but in reality, it is simple. We are talking about something called glucose division, or what is also called flexible dosing. 1. Why do we need glucose division? When you eat breakfast, lunch, and dinner, the amount of sugar and carbohydrates entering your body is not the same. This is normal and logical. Now, you may ask, if meals are different, why do I always take the same dose of rapid insulin with each meal? The answer is simple. We use flexible dosing, which means we adjust insulin depending on 2 main things: the amount of carbohydrates in the meal, the blood sugar level before eating. 2. Step 1. Calculating carbohydrates. Before eating, we calculate how many grams of carbohydrates the meal contains. How many grams of rice, bread, fruit, pasta, pizza, or sugar. After knowing the number, we calculate how much insulin is needed to cover it. This is called the insulin to carbohydrate ratio, ICR. 3. How to calculate the insulin to carbohydrate ratio. If the person uses modern rapid insulin like Aspart, Lispro, or Glulisine, we use the 500 rule. We take 500 and divide it by the total daily insulin dose. For example, if the total dose is 30 units, 500 divided by 30 is equal to 16. This means 1 unit of rapid insulin covers 16 grams of carbohydrate. If the person uses old regular insulin, R, we use the 450 rule. 450 divided by 30 is equal to 15. This means 1 unit of regular insulin covers 15 grams of carbohydrate. With this method, the person can calculate exactly how many insulin units to add for the food they are about to eat. 4. Step 2. Correcting blood sugar before eating. Sometimes before meals, blood sugar is already high. For example, the normal target is 120 milligrams per deciliter, but the reading is 200 milligrams per deciliter. The difference is 80 milligrams per deciliter. This must be corrected by adding extra insulin. This calculation is called the insulin sensitivity factor, ISF, or correction factor. It tells us how much 1 unit of insulin will lower blood sugar. If using rapid insulin, we apply the 1800 rule. 1800 divided by 30 is equal to 60. This means 1 unit of rapid insulin lowers blood sugar by 60 milligrams per deciliter. If using regular insulin, R, we apply the 1500 rule. 1500 divided by 30 is equal to 50. This means 1 unit of regular insulin lowers blood sugar by 50 milligrams per deciliter. So, if blood sugar is 200 and the target is 140, the difference is 60. That means the person needs 1 extra unit of rapid insulin to bring sugar down to the target before eating. 5. Why does blood sugar rise without food? It is important to know that sugar in the blood does not come only from eating. The body produces sugar naturally. Hormones like glucagon and cortisol stimulate the liver to release glucose. The liver can take amino acids and other materials and convert them into sugar. This process is called gluconeogenesis. In summary, flexible dosing means insulin before meals is not fixed. It is carefully adjusted depending on the carbohydrates in the meal and the blood sugar level before eating. With practice, this method becomes simple and makes blood sugar control much more accurate. You might say this is confusing with too many rules. So, let's make it clear with a real example. Step by step, we will calculate everything together. Example, a patient weighs 100 kilos. The doctor says, start insulin at a dose of 0.5 units per kilo. This means the initial dose is 50 international units in total. Step 1. Calculate the total daily dose, TDD. Weight equals 100 kilos. Multiply by 0.5. Result equals 50 units of insulin per day. This is the total dose, which we now need to divide. Step 2. Divide doses using the basal bolus system. The doctor chooses rapid-acting insulin, aspart, together with long-acting insulin, glargine or lantus. Half of the total, 50%, goes to glargine. 25 units, taken once at night. The other half goes to aspart. 25 units, divided between meals. About 8 units at breakfast. About 8 units at lunch. About 9 units at dinner. This way, insulin is balanced between long-acting and mealtime doses. Step 3. Calculate carbohydrate coverage. Now let's focus on lunch. The patient is going to eat 89 grams of carbohydrates. We calculate this using the insulin to carbohydrate ratio, ICR. The patient is on modern rapid insulin, aspart. Rule used equals 500 rule. 500 divided by total daily insulin, 50, equals 10. This means 1 unit of aspart covers 10 grams of carbohydrates. Now, 89 grams divided by 10 equals about 9 units of aspart needed for food. Step 4. Calculate blood sugar correction. Before lunch, blood sugar is 210 milligrams per deciliter. The doctor's target equals 120 milligrams per deciliter. Difference equals 210. 120 is equal to 90 mg/DL2 high. To fix this, we use the insulin sensitivity factor, ISF. With rapid insulin, we use the 1800 rule. 1,800 divided by total daily insulin, 50, equals 36. This means 1 unit of aspart lowers blood sugar by about 36 milligrams per deciliter. Now, 90 divided by 36 almost equals 2.5 units of aspart needed for correction. Step 5. Put all together. Long-acting insulin, glargine 25 units at night. Breakfast, 8 units of SPART. Lunch, 8 units base plus 9 units for carbs plus 2.5 units correction equals about 20 units of SPART. Dinner, about 9 units of SPART. With this example, you can see clearly how to calculate total daily insulin, how to divide it between glargine and a SPART, how to adjust doses based on carbohydrates in food and blood sugar before eating. This is what gives insulin therapy its flexibility and helps keep blood sugar under control in a realistic, practical way. The fifth and last topic with us today is very important. Earlier, we talked about sugar absorption in the blood after meals, after breakfast, lunch, and dinner. But we did not talk about sugar in the morning during fasting. That is, when a person sleeps and then wakes up. How do we explain this morning sugar? Who controls it? The answer is clear: the long-acting insulin. The insulin taken at night before sleeping is what manages fasting sugar. Please pay close attention, because this point is very, very important. My words here are directed to doctors in a precise way and also to nurses. Not every patient who wakes up with high sugar should automatically have his long-acting insulin increased. This is a serious mistake. Why? Because there are two different situations. Case 1. The patient's long-acting insulin dose at night was too low. After 2 or 3 hours of sleep, the insulin effect disappeared. Blood sugar then began to rise slowly through the night. In the morning, the patient found his sugar was high. In this case, the solution is to increase the long-acting insulin. This seems logical and clear. Case 2. The patient's long-acting insulin dose at night was too high. After 2 or 3 hours of sleep, sugar began to drop strongly. The patient did not feel it because he was sleeping. To protect him, the body released hormones such as glucagon. The liver then produced a lot of sugar to correct the drop. By morning, sugar was again very high. But here, the solution is the opposite. We must decrease the long-acting insulin so the body does not release excess sugar. So in both cases, the result in the morning looks the same: high blood sugar. But the treatment is completely different. In one, we increase the insulin. In the other, we decrease it. How do we know the difference? The first case is called the dawn phenomenon. Here, insulin was too little. To check this, measure sugar at 3 a.m. You will find the sugar at that time is normal because insulin is still working. The second case is called the Samajai effect. Here, insulin was too high. At 3 a.m., sugar will be very low. This proves the body reacted by producing more sugar later. The correct approach. In dawn phenomenon, if sugar at 3 a.m. is normal, then increase the long-acting insulin. In Samajai effect, if sugar at 3 a.m. is very low, then decrease the long-acting insulin. So, never assume that every high fasting sugar means you should increase insulin. You must first check at 3 a.m. If the patient is Samajai and you increase insulin, this can be very dangerous. That's enough for today. I'm sorry if I took a bit longer, but this point is extremely important. I hope I gave you clear and useful information. If you like the content, don't forget to like, subscribe, and share. And remember, you can support the channel on Patreon, PayPal, and YouTube. Take care. Hussein Lotfi.